Okay, welcome everybody. This is 12.1 on circles. So to understand the circle equation, you have to understand how the circle is built. And we know that if C here, that purple point is the center for C, the X comma Y, the coordinate of that center point is H comma K. All right. And then here is my radius, right? The radius of the circle is from the center point to any point along the circle. And this particular radius, it went to point P, X comma Y. Okay. So if we get the radius of the equation of the radius of the circle, that's like the equation of the circle itself. Okay. So here we have a right triangle. Okay. What equation, my first question to you is, what equation would you use to solve for the radius? How will we get the radius? Let's say, for example, if this was 3 and if this was 4, how would you get the length of the radius? Anybody?
X times Y.
Yeah, the Pythagorean theorem, right? A squared plus B squared equals C squared. So in that Pythagorean theorem, what's the most important thing is your C. Your C will always be the longest side. So in this case, it's your radius. I'm going to label this my A and then label this my B. Okay, so we are going to use the Pythagorean theorem of A squared plus B squared equals C squared. Okay, so in that triangle or in that circle, the question now changes. If we're going to use this equation, the Pythagorean theorem, A squared plus B squared equals C squared, what is the equation of the blue and green line? Okay, or A and my B. How would we get my A and my B if this point here in red is point P? Yeah. And this point here, my C, my center is H comma K. So I'll give you guys a couple of minutes to think about that. Okay. A hint here, class, is if you look at my B, it's a vertical line. If you look at my A, it's a horizontal line. So use that fact and use the points X comma Y and H comma K to get the length of A and B. So on this vertical line, if we just take B, for example, okay, the Y's would change. The X's would be the same, but the Y's would change, correct? So let's say, for example, if my Y value here was, let's say 4, and my K value here was 1, this length would be 4 minus 1, correct? Yeah, this would have a length of 3, right? Okay, so taking that and just applying my X and my Y and my H and my K, the B value now would become Y minus K, right? Doing the same thing for my A value would be X minus h. You guys see that? Okay. Equals r squared, right? Thinking back to my Pythagorean theorem. A squared plus b squared equals c squared. So my a value was x minus h. My b value is y minus k. So I'm just going to substitute my a and my b for these values here. So that's going to be x minus h quantity squared plus y minus k quantity squared equals r squared. This is the equation of the circle. Where my center is h comma k, and the radius is r, and my x comma y point, right? There's no specific one point for x and y. There's actually infinitely many points, okay? So these are just points on the circle. All right, so going back to my circle here, point P is just one example of many points. So there's a point here, point here, point here, point here, point here. And I can go around infinitely many times, right? Creating these points, right? So there's a bunch of X's and Y's. Yeah. That's what actually creates that circle. Because there's infinitely many of these circles, they're so put together, these points are so close together that they create this circle. Okay? So X's and Y's, we just label them as X and Y. All right? So we know our center, we know our radius, and that's the equation of the circle. Okay? So now, equipped with this, we're going to do some sample problems. The first sample problem is write the equation in standard form. Standard form is this. Okay, what we just did. This is in standard form. Okay? This is the standard form of a circle. So it's always going to be x minus h quantity squared, or x minus h quantity squared plus y minus k quantity squared equals r squared. Okay. So here's my standard form. We all know what h and k and r stands for. And we're given this as our directions. The circle with center C at -3, 2, and the radius of 4. So all we're going to do, class, is we are going to plug it in. Okay? X minus -3, y minus 2 equals r is actually 4. Right? Simplifying that out, we have x plus 3 quantity squared plus y minus 2 quantity squared equals 16. This is the equation that they are looking for. Okay? Simple? All right, and then there's just variations to this. Okay, so this is like step 1 or level 1. Okay, level 2 would be, hey, I have the center and a point where it's -2, 1. Okay, so here is my standard form again. If I have my center, remember, is h comma k, right? The point is x comma y. Yeah, we're not given the radius here, right? And we got to figure out what the radius is. Okay. So again, if I label everything out again, I'm gonna have x minus -2 plus y minus 5 quantity squared. But here I also have an x and a y. So I'm going to erase that x and erase the y and plug in -2 and plug in -1. Yeah. Because I don't know what my radius is, right? So if I simplify this, -2 plus 2 is 0 squared, plus -1 minus 5, that's -6 squared, equals r squared. So that's the 0 plus -6 quantity squared is 36 equals r squared. So my r value, if I square root this, is going to be +6. Why is it only +6? Now remember, we learned if I square root anything, right? If I square root anything from an equation, it's always going to be the plus and the minus, right? But in this case, I'm just taking the positive. Why am I just taking the positive? Yeah, because you can't have a negative radius. Remember, the radius is the length from the center to the circle, right? It's an actual length. It's an actual distance. So if we're talking about actual distance, we have to take the positive because there's no negative distance, right? So here my radius is 6. And then I'm going to plug this back into my equation, which would be x plus 2 quantity squared plus y minus 5 quantity squared equals 6 squared. I'll just leave it like that. And then simplify this again, x plus 2 quantity squared plus y minus 5 quantity squared equals 36. And here is my standard form of that circle. Cool? Yeah? Because we only have one center and one radius, these two things will always be a part of our circle equation. The x's and y's, they vary, right? In the problem here, they only give us 1 point out of the infinitely many points that we can do that point P can have, essentially. Right? Okay. All right. So that was level 2. This is now level 3. Write the equation in standard form. This one, there's a bunch of x's and there's a bunch of y's, right? And now this one, we need that skill that we learned previously of completing the square. Okay? So that in mind, what I'm going to do is I'm going to gather up my x's. So my x squared and my -10x. I'm going to gather them here. X squared minus 10x. I'm going to gather my y's. Notice that I left a little space there because we're going to use that space in a little bit. to complete the square. So I gathered my x's, I gathered my y's. If there's a constant, I'm going to move it to the other side. Okay, so if I do that, then I have equals negative 30, right? Okay. And now I'm going to complete the square twice. One for the x's and one for the y's. Remember, really quick about completing the square, we're going to take the coefficient of my variable, negative 10, in this case. I'm going to half it, and I'm going to square it. Negative 10 divided by 2 is negative 5 squared. That's 25, right? So to complete the square for my x's, I'm going to have to add 25. The value that I added to the left-hand side is 25. So I'm going to add that here as well. Okay, because it's an equation, and whatever I do to one side, I got to do to the other. No, because that's on the left-hand side already. Okay, now I'm going to get the coefficient of the y, half it, and square it. That's 3 squared, so that's 9. So I'm going to add 9 here. If I add 9 to the left-hand side of the equation, I have to add 9 because that's the value to the right-hand side of the equation. So I went through the completing the square process. And if you factor these two out, it's going to be a perfect square. Okay. The first one with my x's, I'm going to have x minus 5 quantity squared plus y plus 3 quantity squared equals negative 30 plus 25, that's negative 5, plus 9, that's 4. Right? And here, class, is the standard form of this equation. Okay? Now I can ask you for the center point being 5 comma negative 3, and my radius being 2. Okay? All right. Questions on how I got my center and my radius? No? Why is it negative 3? It's because this guy is positive. Remember the special or the standard form? Yeah? It's going to be x minus h quantity squared plus y minus k quantity squared. So in order to build the y plus 3, that's the same thing as y minus negative 3 quantity squared. Yeah? So my k value is negative 3. Okay? Cool. That's level 3, I think. Level 4. The difference between this one and the previous one, we're going to take the same steps. Okay? I'm going to gather my x's. 4x squared plus 8x. I'm going to gather my y's. 4y squared minus 16y. If there's a constant, I'm going to move it over to the other side by subtracting 11 on both sides. Right? Okay, set it up the same way. And as I go ahead and I complete the square here, right, to both, before we complete the square, though, there's a coefficient, right, of 4 on both. So I must factor that out. If I factor out a 4, I have an x squared plus 2x. Yeah. if I factor out the 4 in the y's, I'm gonna have y squared minus 4y equals negative 11. Okay, just plop it on there. Okay. If you go through the completing the square process, I'm gonna add 1 here. And I'm gonna add 4 here. Okay. Now, if I add 1, let's take this 1 for example. Okay, if I add 1 there, what's the total value that I added to the left-hand side? No. 4. Yeah. Because the value that I added was 4 times 1, right? So I added a value of 4. So it's not 1 I have to add to this side. It's 4 that I have to add to that side. Okay. Same thing here. If I added a 4 on the inside of my parentheses, I added a value of what? 4 times 4, which is 16. So I'm going to add 16 to this side. Okay. So my right-hand side, I'm going to do this quickly. It's 9. 16 plus 4 is 20. Minus 11 is 9. And I'm going to have 4 times x plus 1 quantity squared plus 4 times y minus 2 quantity squared, right? Equals 9. I am not done yet because in my standard form, right? There is no coefficient or there is no number here or here, correct? But there's a number here and here, right? So what do I do? Well, how can I get rid of it? Or how can I move it over to the other side? If you guys are confused on what to do, say it out loud. 4 times the quantity x plus 1 quantity squared, right? It's 4 times. So how do I get rid of something that I'm multiplying? Divide, right? So I'm going to divide by 4. Divide by 4. Divide by 4. If I divide it by 4, I'm going to have x plus 1 quantity squared plus y minus 2 quantity squared equals 9 over 4. Right? So again, I can ask you what my center is. What is my center here? Negative 1, comma 2. And what's my radius here? 3/2. Yeah? Do we all understand that it's 3 over 2 and not 9 over 4? Okay? All right. Honestly, class, the difference between this problem and the next 2 problems, if you guys understand the algebra behind it, it's just graphing. Okay, so I'm going to go ahead and graph this. Okay, and show you guys how to graph. All right. So I'm going to move this down. Oh, I took the 4 with it. I don't want the 4. Yeah. I'm going to graph that. Okay. So when I graph it, It's just my X axis and my Y axis, or vice versa. Graph my center first. Graphing that -1, 2 is here. Okay? And on your sheets of paper, what I want you to do from the center, from that center point, just go 3.5 or 3/2 or 1.5 units over to the right, up, to the left, and down. Okay? That shows me that, hey, those are the points of my radius if the radius was vertical or horizontal. And then try your best to draw out a perfect circle. And this program does it for me. Yeah? Okay? That makes sense? So I don't care, and no teacher would care about how good the circle is. Yeah, unless you have a protractor or a compass to do it, right? Just try your best to make it look like a perfect circle. Okay? With these points shown, I gotta see these points. Four points there and the center. All right? If I see those 4 points and the center, then you should be good. Okay? Questions? That's your lesson for today. Thank you, and I will see you on the next one.